We will now look at the first part of the in-class exercise for week 3. The first question over here asks you to look at a given list A of n numbers, and we are given the guarantee that n is greater than 10. So your task over here is to find the largest element of the first 10 numbers. The code is given to you, so you do not need to do anything in terms of the design. You just need to analyze that. We will be demonstrating a comprehensive steps that usually will be taken that eventually will lead to the quantification of the complexity. We will be calculating the numbers of comparison operation, which is in green over here, right? And also the numbers of assignment, which occurred at two different places being labeled in blue. The first is over here. The second is over here. Okay, so let's see how do we do the counting first. In terms of the comparison, you can see that it's decided by the numbers of times that the for loop got executed. It's actually in the range from 1 to 10, right? So we know from last week when we go over the for loop in Python, range, right? If you write it down, range 1 to 10 generates the sequence of 1, 2, 3, all the way until 9. Right? So in total, you will have 9 elements, 9 items, which means that if you focus on only the comparison operation, it should be executed exactly 9 times. So for the assignment, there's a bit of uncertainty. For sure, over here, this is the first time, right? But if you look at the second occurrence of the assignment operation, this operation will only occur if the condition in the if statement stay true, which means that the numbers of times that the second assignment operation got executed depends on the content of AI. Highly uncertain, we don't really know. So in this case, I think the usual strategy is that we will try to look for the worst case situation, right? So we just look at the worst case scenario. So in the worst case, for each and every conditional statement if, we assume that this assignment operation will happen, which means that, I mean, because the condition statement is evaluated 9 times, so this part of the assignment, in the worst case, at most, right, also 9 times. Okay, so you have 9 plus 1, so in total, the numbers of assignment as a result is at most 10 times. Or you can simply say that this is the worst case scenario. Okay, so I think this is the question number 1. Then we can look at the question number 2. This is a very typical type of question you will encounter when you try to quantify the complexity of a real code. Over here, you can see that the complexity difficulty in analyzing this kind of question is that you have two for loop, the outer loop and the inner loop. In a more complicated case, you can sometimes even have 3 different layers. But once you know how to do it, the 2 layers, you have no problem doing 3 layers. Here we have one additional type of operations called subtraction. So again, being labeled in different colors. So we start with the green color over here. Okay, so if you look at the comparison operation, you get executed every time that you enter for a particular I value, for a particular J value, you will execute one comparison operation. So in other words, the numbers of comparison operation should equal the numbers of times that you execute this nested, this 2 layers of for loop. In the first glance, you will see that it's not very easy to analyze because for the outer loop, yes, you have a definite range, which is from 0 all the way up until the upper bound is at -1, which means that the largest value should be at -2. But for the inner loop, you see the lower bound of this particular range is actually a variable I. It depends on the current value of the outer loop. So it's actually variable. Every time you execute the inner loop J, the actual range depends on what is the I value, right? So that is the major difficulty. So again, there are multiple ways where you can tackle this. I would recommend you try to create the following table. It will help you in reasoning multiple layers. So I will put down for the first column, this is i's value. And then for the second column, that's all the possible j value according to the given I value. And finally, I will count the numbers of j element, numbers of j's. Okay, so let's see how it goes. The smallest I is actually 0, right? So when I equals 0, the range of j start from I plus 1, which is 1, which means that you go from 1, 2, 3, all the way until the last one is actually the length of A, which is over here, which is the n minus 1, right? So that is the largest j value, n minus 1. So if you count the total numbers of elements, it will be n minus 1. So now we try I equals 1. You see, the purpose why we do this is I would like to try to discover the pattern. Once you discover the pattern, you feel that it's okay, you can cut short of that, you can go straight to the last I. Okay, so here, if we look at it, because i's value equals 1, your lower bound is I plus 1, means that you start from 2. So you have 2, 3, again, the upper bound stays the same, which is n minus 1. So the numbers of element is actually 1 less. So now you only have n minus 2 element. So we can do one more I value, so we can have a clear view of the actual pattern. So now I equals 2 means that j start from 3. So you go all the way until n minus 1. It give you n minus 3 j elements. So you can continue to do so. So for completeness, we will look at the last I value, which is n minus 2 in this case. For the case of n minus 2, uh, your j value is I plus 1. So it's actually n minus 1. And it terminates immediately. So in total, you only have a single element. And the numbers of comparison we said is the numbers of times that this inner loop get executed. In other words, the total numbers of j's get evaluated. So that will be the summation of all this value over here. Okay, so if we do a little bit of calculation, right? So essentially, what we are getting at is that we will be summing up all this value. So numbers of comparison as a result will be 1 plus 2 plus 3 plus all the way until the largest number, which is n minus 1. So for those of you who have seen this series before, this is the arithmetic series, and the sum of arithmetic series is as follows. You take the first element plus the last element's value, right? And then you divide that by 2. Then you multiply this by the numbers of turns. In this case, you have n minus 1 turns, so you multiply that by n minus 1. So this will give you, yeah, this 1 plus n minus 1, so you got n, right? So the total will be, as a result, n times n minus 1. This will be the numbers of comparison. Okay? Numbers of comparison. So numbers of assignment will be evaluated very similarly like in question 1. So you see that you have one assignment over here, right? You have one assignment over here, and you have one assignment that's inside here. But the second assignment here is dependent on whether or not this condition is true. So it's uncertain. But we want to evaluate the worst case scenario. So in the worst case scenario, every j will be associated with two assignment operation. So in other words, we know that the total numbers of comparison is this value over here, n times n minus 1 divided by 2. So the assignment as a result, right? We just write it down here, number of assignment operation, right? Will equal this n times n minus 1 divided by 2. In the worst case, you'll multiply this by 2 because this one, you just assume that it will somehow just happen, right? And then there's one more out there, so you plus 1. So the numbers of assignment operation as a result will be n times n minus 1 and then plus 1. Finally, the subtraction, right? So a subtraction happen over here. For sure, for every j value, there will be one subtraction, and there's one more subtraction that's outside. So it's going to be total numbers of comparison plus 1, right? So for numbers of subtractions, it's very similar to numbers of comparison. It will equal n times n minus 1 divided by 2, but you increase that by 1, which is accounting for the very first one over here, right? So that will be the total numbers of operation, right? So if you want to find out the total numbers operation, you will sum up this value over here, and this value over here, and this value over here. Okay, so if you want to do a little bit of total summation, right? So I mean, just to conclude this part, the total will be this one plus this one, right? So kind of this 1 over 2 cancel out. So you have this n times n minus 1. And then you have 1 and 1, right? So that's 2, right? You have one more over here. So you still need one copy of this. So the real total as a result is 2 times n minus 1 plus 2. That is the total numbers of operation. Okay, so I think for the part one of the exercise, we'll stop here. But later you will see that after we learn how to represent complexity by using big O notation, we can further simplify this by using the big O notation.